Yeah, Morgan, you remember all the
Yeah,
steps that we took
yeah. I
from?
mean, I think it was a series of questions that we were trying to answer. Um, and like it started out like we knew that we could do something that was very simple that looked roughly like a character, and we knew that we could do something more intelligent with this like brick shaped object. But then the question was, could we, you know, there's a lot of unknowns. We ultimately, what we thought would be really cool would be a character that was full scale and that could look like a performer, but that could also do some of this intelligent stuff and control its motion. And what we weren't sure about was there were a lot of unanswered questions there, which were, you know, how are you going to throw that? How is it going to survive? How is it going to land? Um, is it can you even get enough power uh, on board to make it work? Like it's for you know, if you're really spinning around, doing a tuck can be very power intensive, and you don't have that much time in the air, so you have to have a combination of both torque and speed. And there's limitations on what motors can accomplish. So we actually spent a lot of time early on trying to just figure out what actuation technique we'd use. So we actually explored significantly, spent a good amount of time exploring pneumatics because we knew we could get a lot of power density out of a pneumatic actuator. Um, and what was maybe surprising is that we also were exploring electric motors, and what we found is that it was a lot easier to get the kind of smooth motion that we wanted out of electric motors right off the bat than out of the pneumatics. Pneumatics, the easiest way to use the pneumatics is kind of binaries, and what we found that maybe was a little bit surprising was that we needed that smoothness added a lot of added life to the character and helped us believe that it was really a performer. And so even though the power density wasn't quite as good with the electric motors as it was with the pneumatics, we ended up being pushed that direction because it was so much smoother and more lifelike. And we are willing to make some sacrifices on the speed of a tuck or you know, the weight of the robot itself, and work, you know, to bring that total, do some more serious design work in order to make the electric motors work because it had such a nice effect in the way it made you feel as you were watching the robot, and you're able to get these subtle, more expressive motions.
Yeah, there was a big milestone in our development of this, and this when we moved from uh, our big pneumatic figures to half scale all electric figure, and then shooting video of that slowed down to be in alignment with if the figure were full scale, how fast would it move through the air, and then watching the video slightly sped down as maybe 70% or so of the actual speed, I want to say, um, uh, and shooting that video from up in, you know, a scissor lift at the right altitudes and from different angles, without much around, to give you a sense of what is the true scale of that figure going through the air. It to our eyes felt like, oh boy, this is not different from how a human acrobat would do the same type of pendulum swing and then, you know, release and do somersaults. So that was the part that gave us a great deal of encouragement that the next thing we needed to do was go to a full-size electric figure and move outdoors outside of a building where we had the headroom to launch this robot and get as much airtime as we could out of it, so that we could do the most amount of things in the air to hopefully get that breathtaking response. And that's a thing that we sort of also crept up on as we added more power to our launch system. And we realized that there's an altitude above which this feels like we have something that's superhuman.
Yeah,
And
that's actually, sorry, go ahead. Sorry
yeah,
to finish your thought there.
please finish that thought.
No, I'm just excited because that's something that was a true surprise for us, is that as we were throwing the robot higher and higher, um, there was this moment that Tony talked about where uh, it's in the air so long that it feels wrong. It feels like it should have come down by now, right? And it's like you're something elemental in your brain is like, something that something shaped like a person shouldn't be in the air that long, and it kind of gets a second emotional reaction from you. It's a big reaction when the thing is launched. When the character is launched really fast, you get a big emotional reaction. But then there's this secondary one where it's like, shouldn't it have turned around and start coming down by now? And that's, if you get above, for us, I think about 55 feet was where we started noticing that, and that was unexpected and really cool. And again, a very much not like something that you can't really put down as a technical specification in a conventional robotic sense, but something that very much popped out of this, like, being really caring a lot about what the human is experiencing.
I think it sort of ties into this connection you have with the robot character. Becomes a feeling of empathy. If you can now relate to, gee, what would happen if I were 65 feet in the air and coming down from that height? There's a thing that makes us all feel something very powerful, and that's sort of we got a taste of that with our Spider-Man Stuntronic figure, and so that has us now thinking in that mode constantly. Where else can we find these moments that we can do with the performance of a robot that brings out these very powerful feelings?